So this week we're just reviewing. If you have any late material, you need to get it in by May 7th. I can't take anything after Friday, May 7th at 11:59. The following week is finals week. Your final is in 2 parts. One part will be up on Saturday, and it's a take-home part. It's due May 7th at 11:59. Part 2 is the in-class part. And you can take it Wednesday, May 5th is the schedule for this class. And it's from 8 to 10. So you do not have a final on Wednesday other than ours. On Wednesday at 8 to 10. You may have a different time. But if you'd like to take it earlier, you can take it Monday. I had a student coming at 9, but someone else wanted 8, so I have 8 to 11 on Monday. So you can come one of those 2 days. If you're working and you need to come at an evening time, let me know and then I'll figure out an evening time. Yeah, Monday you can come in at 8 or 9. You only have 2 hours to take the exam, but you can come in at 8 or 9. Because I have a couple people at 9 and then a few more said they could do it if it was 8. So. Any other questions? Okay. Test. This is, I think it's up on Blackboard. I know I emailed it a couple days ago. But if you want to see the grade that you need, first thing you want to do is look up your current grade. And that's on Blackboard. And then the final grade that you want. An A would be a 90, 80 is the B, and 70 is a C. And I didn't put the other ones because we don't want them. Plug them into this equation and just calculate it. So I said that my current grade was an 89. I want a 90. So to see what I would need on the final, I just plug them in. And it comes out to 93. So out of 100, I'd need a 93. If I wanted to make sure if I messed up that I didn't go below the B that I have right now, I put in the 80 for a B, kept my 89 and calculated it. I'd need a 53 on the final. Depending on how high your A is, to get a C, you probably could get a 0 on the final. But it's mandatory to take the final. So if you don't take the final, you get an F in the course. But I think even if you had 100, oh, you might. Oops. Yeah. If you calculate this, you get a negative 20. So if you had 100% in the course, you could actually get a 0 on the final. But if you have 100% in the course, you're going to get 100 or at least a high A on the final. I've never seen anyone drop. I've seen people move up, but I've never seen them drop because of the final grade. So even if you do not need any points on the final to pass the class, the final is mandatory. Any questions on that? final exam has 10 problems for the in-class part and 15 for the take-home. And we went over this last class. I'm not going to go back through this, but it is more explained in Monday's video. So you can look at Monday's video. We were on homework chapter 10. There's 2 problems. And we did number 1. And we were going to do number 2. Because one of these would be on the take home and one will be on the in-class. I don't want to do the same exact problem because we've already done that. You can look under chapter 10 homework. So we'll do one a little bit different. So if we put $300 in an account, at 6.2% per month, how much is in the account after 3 months? Okay, so we put $300 in an account. And the $300 we're putting every month when we get our statement, we'll put another $300 in. When you open your account and you put your $300 in, at the end of that, since it's monthly, at the end of that month, you will get interest on it already. So when you do the credit card and you charge something, that first month you don't get charged interest. And that's why it's 0. But on this one, at the end of the first month, you do get charged, or not charged, but this one's interest that you make. So you take your balance that you put in at the beginning of the month and multiply by the percent written as a decimal, so 0.062. We multiply these, you get $18. So in the first month, you made $18.60. When the statement comes, it will say previous balance $300 plus interest $18.60, and then it'll give you a total $318.60. Oh, wait, we didn't add ours. So there would be $318.60, but we are going to add $300, making it $618. Any questions so far? Now at the end of the second month, then you'll make interest on the 618. Which is $38.35. Go ahead and find the last row. For the balance, we had the 618 and we're depositing another $300 plus the 38.35 gives us $956.95. We have the 956.95. Any questions on filling out the table? How much is in the account at the end of the third month? Anyone? You can put it in the chat. How much is in the account at the end of the third month? We add these two together and we get 1,016, yeah, 28. How much of the money is it that we put in? Anyone? 900, because we deposited 300, 300, and 300, which is 900. How much interest was made? Two ways we can find it. No. One way is to add, there we go, 116. One way is to add this up. The other, if you take and subtract these two, because this is how much is in the account. This is what we put in, subtracting them gives you the interest. So either add this up or do both and make sure they match so then you know you didn't make a mistake. But you should get $116.28. Any questions on that? The third one is the house payment. And here's the formula. We'll do a different problem since you've already calculated this one and can practice it. We'll deposit, or not deposit, but buy a house for 300,000 at 6.3% interest rate, 6.3% per month. Most home loans are either 30 or 15, so we'll do 30. Find the payments. And the formula, P times R over 12. And if you're entering it all at once, that would have to be in parentheses. Same thing with the bottom, 1 minus 1 plus R over 12. Then the exponent on this part, parentheses here, is a negative 12 times the number of years. Now, if you're entering it all at once, unless your calculator has fraction bar, you have to have all these parentheses. And this one is in the exponent. So you either use a caret unless your calculator goes there, or you have to use the X to the Y key. P is the amount of the loan. If we're not putting anything down, it's the 300,000. R is the rate, which is 6.3, but you have to write it as a decimal. And Y is the number of years. This one is 30. So go ahead and find the payments. Are we getting 1,856? And 92 cents? Is everyone getting this? One thing you could do is multiply across the top first. And if you do that, you get 1575 divided by, and then on the bottom, 1 minus 1 plus. If you are doing it in parts, keep the whole decimal. You don't have to write it all out, but keep it in your calculator and use it. And then if you divide these, you'll get this. Any questions on the payment? To find the total paid, on the homework there was a hint, but I wouldn't do that on a test. But it's your payments times 12 because you're paying them monthly. There's 12 months in a year times the number of years. So payments would be the amount we're paying, 12 months in a year for 30 years. So it's $668, $668,491.20. Any questions on that? How much interest was paid? Anyone? This is the total we paid. This was the cost of the house. So anything over 300,000 was interest. So if we subtract them, so we are paying $368,491.20. We could buy another house. Any questions on that? This one will be combined with number 4, which is the effective rates. In these formulas, I would put a formula sheet and have all of them. Since it's open notes, I probably won't put the formulas on a test. For effective rate, there's 2 different formulas. This one is with a compounded amount, and this is compounded continuously. Find the effective rate. Well, this one we already did. So let's do, what was this? 6.3. Since we already did this one. So 6.3% compounded monthly. A compounded amount is this one, and C is the number of times it's compounded in a year. So in this problem, C would be 12 and R at 6.3.063. And then we just plug it into this equation. 1 plus 0.063 divided by 12 to the 12th minus 1. The biggest mistake, this minus 1 is not in the exponent, only the 12. Let's round 3 decimal places to the thousandth. So when you plug this in, you should get this. Now, for the answer, you want a percent. So we'd move it over to here, 10, 100,000. So this would be the thousand. 6.485. And that'll stay a 5 because this is a 1. So 6.485%. 6.3% compounded monthly is like 6.485% per year. Any questions on that one? The next one says quarterly. If it's compounded quarterly, what does C equal? 4. Quarterly is 4 times a year. You could think of 4 quarters in $1, but it's 4 times a year. We're keeping the same R. So you should be getting this. Then multiply it by 100 or move the decimal over 2 and then round to, we said 3, the thousandth, 10th, so it's here. 6 point. That means that 6.3% compounded monthly is like 6.45% compounded quarterly. So it's giving you, if you did it per year, the rate. And then this one's continuously. Is there any questions on plugging these two in? Continuously uses this formula. And that key is with your LN key, depending on your calculator. This one is right here with the LN. And this one is up here. So both cases, you have to hit the second button to get them. Now our R, we're keeping the same, so it would be E to the 0.063, and then -1 is down here. So make sure you go back down. And my calculator, 0.063, I close the parenthesis before I subtract 1. Multiply by 100 to make it a percent. We're rounding 3 decimal places. So that 6 is going to make that a 3. So for each of these compoundings, this tells you how much you make approximately per year. It's taking into account making that interest in there. And this calculator, second E, 0.063, close parentheses before you subtract the 1. Same thing. Here. This one, some calculators, when you go into the exponent, shoot. Okay. Here's the e to the x. Notice it put it up in the parentheses, so then I put 0.063, and then you have to hit this little arrow to go back down. -1. So if your calculator puts it up there already, then you have to use your arrow to come back down. Any questions on that? Chapter 11, the one on the timed in-class test will be similar to this one. The fare ticket price. So we'll make a problem. We have gonna have a raffle, and we have 500 raffle tickets. And we're going to have 3 prizes. A $300 prize, a $200 prize, and a $100 prize. If we buy 1 ticket, what's the probability of winning the $300 prize? Anyone? So we have 500 raffle tickets, 3 prizes. What's the probability if you buy 1 ticket? What's the probability of winning the $300 prize? Mm-hmm. 1 out of 500. What is the odds of winning any one of the 3 prizes? Almost. That would be the 3 divided by 500 would be the probability. So the probability of winning any one of them would be 3 out of 500. For odds, yes. The only thing is make sure you use the colon instead of the division, but yes, Elise. 497. So 3 to 497 are the odds of winning. Remember that these should add up to the total, which is 500. When you're finding the probability, you're dividing by the total. So the odds of losing, there's 497 tickets that are losing and 3 winning. So it would be 497 to 3. Any questions on that part? What is the fair price to sell the ticket? That's fine, go on. Remember, for the fair price, you find out how much money you're giving out and then divide by the number of tickets. So amount of prizes, we had a 300, 200, and 100. And we're selling 500 tickets. So 600 divided by 500. You're getting $1.20. So the fair price to sell the tickets for is $1.20. If you sell it for $1.20, then you're not making any money. Everything that comes in will go out in these 3 prizes. There's nothing extra. Any questions on that? So when you're doing a raffle, you want to find the fair price. One, to make sure you make it more than that so that you do make money, and you don't want it less than this, or you'll have to pay out money out of your own pocket. Also, you have to think about other fees because you had to buy the tickets. Not much else unless you're hiring people to sell them. But $1.20 each, you will just have enough to pay out the 3 prizes. Any questions on that? If we sell the tickets for $3 each, how much money will we make? Two ways you can think of it and solve it. How much money will we make? Type it into the chat or say it out loud. $900 exactly. There's 2 ways you could have done it. You could have first, if we're selling them for $3, everything over $1.20 we make a profit on. So we could subtract these and see how much we make per ticket. So we're making $1.80 on each ticket. We're selling 500 tickets. And $1.80 times 500 gives us $900. So that was one way. Another way we could have done it, if we're selling tickets for $3 each and we're selling 500 tickets, we're going to make $1,500. But then we have to give 300 for one prize, 200 for second prize, and 100 for third, which leaves us $900. So either way, depending on your thought process, either one of these, you're still going to get the $900. Any questions on that? So if we needed $1,000 for for a trip, school trip or something, then we would not have enough. Any questions on that? Okay. Number 12, or chapter 12, there's one problem similar to these. Let's look at this first one. I wrote two different ones I wanted to look at. Okay, so let's look at this one. You're flipping a coin and rolling a die. If we flip a coin, that's two possibilities, a head or a tail. If we roll a die, there's 6 possibilities. But each one, if I toss a coin, it doesn't matter whether I get heads or tails, rolling the die is not going to be affected by that. So that makes it independent. When you're finding the number of outcomes, you multiply each of the possible outcomes. So when I toss the coin, there's 2 possibilities. When I roll the die, there's 6. So that gives me a total of 12 outcomes. I only asked for one because some of them have a lot. In this one, there was only 12, so you could have written them all out. Whereas in this one, rolling a die twice, 6 times 6, there was 36 of them that you would have to list. So in this one, there's only 12. If you had to list all of them then, it would be a heads and a 1, head and 2, head 3, and tails. So any one of these were possible outcome here. This one asks for the probability of a head and a 3. Well, if we look, when you write all of them, it's easier to find your probabilities because there's only one of them out of the 12. So it would be 1/12. What's the probability of a tail and an even? Anyone? Tail and an even. Not half. Tail and an even, there's 3, not all 6. And because it's sorry. So tail and even would be 3 out of the 12. Or 1/4, but you don't have to reduce. And then probability of tail or even. Or means it could be either one. So it could be the whole bottom row, all 6, or any of the evens on top. So you need to be careful of the wording, and it has to be both a tail and an even, which there was only 3. Or can be either one. So it'd be the whole bottom row, 6, and then 7, 8, and 9. Any questions on that? An example like this, these two were dependent, but I want to do a different example. We have a deck of 52 cards. We pull one card. Do not replace it and pull a second card. Dependent or independent? It's dependent, yep. Because since we're not putting it back in, then the next time we pull, we don't have all 52 cards. We've changed our probabilities. And so if we did put it back in, it would be independent because we'd still have all the cards. Since we're not putting it in, it's a dependent. Oh, wait. Before we do the probability, how many outcomes are there? For the number of outcomes, when we pull the first card, there's 52 possibilities. When we pull the second one, since we're not putting the card back in, there's 51 possibilities. So there's 2,652 possibilities. This is a case where you wouldn't want to write them all. Any questions on it though? So when I pull the first card, there's 52 cards there. Because I didn't put it back, the second one is 51. So this is my total possibilities. Any questions? Probability of the first card is a heart. Well, there's 13 hearts out of the 52. I don't know why I put the P there. And then the second card is a diamond. Well, if we pulled a heart, we still have all 13 diamonds, but we only have 51 cards. So 13 times 13 would be 169 out of the 2652. Any questions on that? Okay, so the only thing was 13, which we have time on Friday. But for Friday, see if you have any questions on your tests, because these problems we've gone over and we just did them last week. But there'll be 2 problems on the in-class part. One will be similar to this one where it's all written out and I ask the probabilities. The other one you'll need to fill out the table and answer them. Any questions?